The topic presented about magnetic abrasive finishing. Already you studied about what is abrasive machining process and also what is meant by water jet machining process. Likewise, you may study it. In traditional machining process also there is abrasive process available, which is known as grinding process. You may utilize aluminum oxide and the silicon carbide as a particles, ceramic particles for utilizing the for making the grinding wheels. In that, resins and additives are used to make a grinding wheel. Based on the grinding wheel, we make a surface finish process. Okay, in that the very high accuracy we can't achieve, so that we utilize some non-traditional machining processes also. For the reason, magnetic abrasive finishing is utilized rather than uh, magnetic float polishing. The magnetic abrasive finishing is utilized. Okay, so, what is mean by magnetic abrasive finishing? Magnetic abrasive finishing is one of the non-traditional machining process which utilized granular magnetic abrasive particles uh, are used as a cutting tools, and the necessary finishing pressure is applied by an electromagnet generated magnetic field. Here, the levitation force is applied for making a magnetic particle accumulation with each other, and also from this accumulated magnetic force we can use as a magnetic grinding wheel rather than resins used for making a additive force between the uh, particles, tool particles, so that magnetic abrasive particle used as a process, non-traditional machining process. Here, the tool does not touches with the workpiece material, but the floating particles, magnetic particles, touches the workpiece material. From that, we can achieve the surface finish process. Here, the abrasive grains are used as like aluminum oxide, silicon carbide, and also diamond. Okay. Here, working principle of the magnetic abrasive polishing finishing process is first, the figure A shows a rotating magnetic pole and also flexible magnetic abrasive brush which made up of from levitation force of magnetic field and also the accumulation of magnetic particle with each other. By utilizing this magnetic particle with each other, the combination utilized for making a surface finishing process, so that the AI diagram shows about plain magnetic abrasive finishing of magnetic work material. Here, the workpiece material always magnetized. With this workpiece material only we can utilize for magnetic abrasive finishing. And also the schematic diagram, the B shows the force applied on the workpiece material. The Fm1 is the normal force and the tangential component Fmt act parallel to the workpiece surface, and also the magnetic force Fm, which is the resultant force of normal and the tangential force. From this, we can achieve the cutting force for remove the workpiece material, and also FMAB, a force also available with this magnetic abrasive machining. Here, what is FMAB? FMAB is the cutting force acting on an abrasive particle. These are all the forces are important to remove the workpiece material for making a working procedure of magnetic abrasive finishing process. Here, when there is a relative motion between the FMAB and the workpiece, already you know about what is meant by FMAB and the workpiece. Abrasion takes place to give a polished finish. This finish can be as good as approaching to 50 nanometer, depending upon the machining conditions and the workpiece material, so that we can achieve nano meter size finish with the rate of magnetic abrasive finishing process than micro finishing accuracy. The performance of the process depends on the parameters such as magnetic abrasive polishing, the working clearance, and the rotational speed of the poles, the feed motion of the workpiece, vibration, the properties of the workpiece material, and the magnetic flux density. These are all the responsible factor in magnetic abrasive performance and the polishing process we can achieve. The magnetic abrasive polishing process considers the types of type and mixing ratio of magnetic abrasive particle, the gap between the workpiece surface being finished and the bottom face of magnetic pole, and also the motion associated with the x direction and the y direction, and also vibration. Vibration means frequency and amplitude of the generated force. These are all the factors to be considered to decide the best performance from magnetic abrasive polishing process. Okay, and then figure B. Here the figure B available. Here figure B shows the magnetic force. Fm means magnetic force and its components. The magnetic normal force. Already from the sketch I explained what is Fmn and Fmt and Fm. Fmt is the tangential force and Fmn is the normal force and Fm is the resultant force of both things. So that the Fm and its components, the magnetic force and its components, as like the magnetic normal force acting on a map due to the magnetic field, and the tangential force acting mainly due to the rotation of the spindle. Then there is a small contribution FMT, which is tangential magnetic force, to this force FC, the resultant force as a component of FM, which is magnetic force. The figure A, already figure A available. The figure A shows a schematic diagram of a magnetic abrasive finishing setup for plane surfaces. Okay. From this diagram, we can aware about the major elements of the magnetic abrasive polishing process setup. Here, the internal machining process also carried out with this magnetic abrasive polishing process as like honing process. Here, the same magnetic particle utilized, and also the magnetic field is produced with the aid of a magnetic circuit, and the internal spindle are utilized. The slip rings are utilized for making a magnetic field within the inner surface, and also we may make a north pole and south pole with respect to the magnetic field. Here, workpiece fixture available. We can fix the cylindrical workpiece on that fixture, and also we can measure the forces applied tangential magnetic force and normal magnetic force with the aid of available dynamometer. Okay, the X motion and Y motions are given by the aid of table, cross slide, and the spindle movement. Here, the realistic image available. What are all the parts available with this realistic part? We can see. According to that figure B, here figure B and figure A is represented schematic diagram of internal abrasive machining process. The B is represented the schematic diagram of plane magnetic abrasive finishing process setup. Okay, here column of milling machine. Here the number one column of milling machine. Number one represents column of milling machine, and two represents here the slip rings are available, and then three F map is available, which is three F map, and then fourth ring dynamometer. Ring dynamometer are utilized to measure the magnetic forces, which is normal and tangential forces. And then fifth one is slip ring attachment for creating the very strength magnetic field inside the cylindrical part. We can utilize this slip ring attachment. So the surface roughness we can achieve nanometer size micro surface finish with this setup, so that before finishing, the surfaces are within the range of micrometer finishing, which is 5 and minus 5. Here RA value is 0.58 micrometer. And then we can reduce that 0.58 micrometer to 0.11 micrometer with the aid of magnetic abrasive finishing process. So that these two are surface roughness plots with respect to surface roughness tester before finishing and after finishing diagrams are represented with this slide. This and also this process can also be used to improve the surface properties by the process of diffusion of traces of magnetic abrasive particles into the workpiece surface. And then proper tooling can be developed to finish 3D intricate shapes, because FMAP adapts to the shape of the workpiece. However, it is not as flexible as the abrasive machining medium. Achieving uniform surface finish near the discontinuities or edges in the magnetic folds is difficult. As irregularities, the magnetic flux density is greater, hence the rate of change in surface roughness is also higher compared to other areas. There are various other areas in which research needs to be done, such as workpiece surface temperature and the forces acting on the workpiece during magnetic abrasive friction. Here you see the internal magnetic abrasive process. Here MAF can also be used for finishing internal surfaces. How the internal surfaces are cleaned or finished with the MAP process. Here the compressed air applied to the pressure gauge. The pressure gauge reads the how much of pressure is applied on the flow of fluids. After that nozzle is available. In that of nozzle, the pressure is reduced and the velocity is increased. Then these accumulated particles are flowing inside of the tube. From that outside of the tube, there is north and the south pole is available. Based on that pole availability, the particles are enter the side wall of the tubes. From that, the abrasion process is carried out, so that the magnetic force, the abrasion process carried out inside of the tube. From that, we can machine the internal surface of the tube. After completing this, the magnetic pole is attract to the magnetic pole is available. The pole is attracted all the magnetic particles surrounded inside tube, and then these particles are held inside of the abrasive tank. Then, when the MAP jet comes into the domain of magnetic field, the particles slightly divert towards the source or pole of the magnetic field, which means the internal surface of the workpiece, and move forward due to an axial force. Here, shearing operation is carried out, shearing the peaks of the internal surface. So, the path of the jet of magnetic abrasive particles is slightly deviated due to the magnetic field force, so that the MAP flow abrades the internal surface of the tube. From that, we can achieve the higher surface finish with the internal surface of the tubes also.